मेरा प्यारा बच्चा लोग कैसे सब? Hi, hello everyone. Hi to all my legends and warriors in the classroom. So please do let me know that I'm audible and visible in the chat box. कैसे? Yes, give me an amazing thumbs up, or those who love me more or those who love physics more, instead of thumbs up you can post a heart in the chat box. Jaldi se jaldi everyone turant. And this is your Ameer Bhaiya, physics educator at Unacademy. So I'm going to look into the chat box, okay, and I think you will let me know that how much energy you all have stored for this particular session through this chat box. Hi crazy girl, Sankamitra, Palak, then we have Bhavin Kumar, Rashi, King, Prabhat, Sankamitra, then Shreya, Miara, then we have Sasta, Rashi, Palak. Oh my god, I'm so happy to see this energy in the classroom. I'm so happy. So this seems like for the entire day you were actually waiting for this classes, right? Okay, very good, very good, very good. How was my day? My day was, let's say, it was awesome. I was happy. There was no specific reason for me to be happy, but I was happy. I was always having the smile on my faces, just like it was, okay, throughout the day. Anyway, I'm doing good. I hope everyone in my class is doing good. Don't worry. Today in our class, you know, to make you more and more happy and to make you more and more cheerful, we'll be doing so many circuits where we'll be finding out the effective value of resistances. I know that you already have some basics of finding out the equivalent value of resistances from your 9th standard and 10th standard classes, but there you only have used limited amount of theory and limited amount of problems where finding out the equivalent value of resistance, hai na? Which means I think you might have used only parallel combination and series combination and finding out the equivalent value of resistances by using this formula. But this is 12th standard and you are going to be seeing lot many tricks and a lot many formulas and tips to find out the effective value of resistance. This is going to be so much amazing. Don't miss the session. I want every one of you to stay till the end, okay? It's for your best and you will love it, because you know that when a question is being asked from the chapter of current electricity, you will be getting a question from the part of resistors or finding out the effective value for resistors. Very good. So yes, let's get started with our session. Whoever is seeing me for the very first time, a bit of introduction about myself. You can see I have an experience of more than 3.5 years in the field of teaching. I'm a BTech graduate from NIT Calicut in mechanical engineering, and I thought and mentored many students, and this is my entire whole story, you know? So if we proceed further, you can see the schedule for this particular week. This will be the last class for this particular week, and the next class will be happening on the next coming Monday, which is 11th of October, and there will be mainly talking about cells. Okay, we'll also be talking a bit about resistors, but mainly our topic of discussion on that day will be regarding cells, and I think that is a new information for you. Don't try to miss that session. Then regarding the Telegram channel, why it is important to join? Because I know that you would love to learn with all your amazing educators live, right? So if you want to catch them live, you want to get the notifications on time, and this can only happen once you are a part of Telegram channel. The link is given right here, okay? Regarding the Emerge program, you all must be very well aware that the term 1 examination of CBSE is going to be happening with a new examination pattern. Okay, what is there? Multiple choice questions and assertion recent type question. So in order to ace this exam, get an amazing score for this exam, you must be knowing how to deal with these kind of questions, right? So for that you should be having enough practice, and that's why Unacademy, who loves their students so much, has started with the Emerge program. And here every week live mock test will be conducted, and whoever is becoming or whoever is getting a very good mark up, बहुत famous हो जाएगा, which means your photo, your name, everything will be there on the social media handles such as YouTube, Instagram, and these kind of stuffs, okay? And I hope you can see the dates of each and every subject, and the time is here, 5 to 6:30, completely free. Come and enroll for it and improve your efficiency, okay, and improve your practice in solving the new examination pattern questions. Then one last thing, I'll talk about why Unacademy subscription is so much important and why this is the right time for every one of you to make the subscription. Okay, give me 2 minutes, then we'll start with our session. Just listen to me. You know that everything nowadays is available in the YouTube, है ना? हाँ, बिल्कुल. Now, why Unacademy subscription is so much important? Because in the subscription platform, we all teachers, including me, will be teaching with a proper schedule targeting board exam, JEE exam, and the NEET examination. And we'll also make sure that all the topics are being done in a proper order, and you can keep track of whatever the topics is being covered in the classroom. And once everything comes in the order, what happens? Yes, the process of learning will become super simple. You all will be tension free, and you can learn and prepare for all the examination in the best way possible and get the maximum marks you can get from those exams. One thing, top educators of the country who's already having a very good experience in the educational field will be there in the Unacademy subscription platform waiting for every one of you. Once you start learning with them, right, you will be knowing what are the kind of questions you should be expecting for the examination. Why? Because that particular educator will be telling you because of his experience. He'll also be telling you the examination strategy, everything, examination pattern from 0 to 10, he'll be telling you. You just want to follow, and once you follow, your dreams are going to come true and you are going to end up in the colleges whichever you are dreaming about. Then study materials will be given to you. Practice test and live test series will make you super confident and will bring out the best from every one of you. And for all these amazing features, you should be going for the plus subscription. For 9 months, it will cost you how much? 1,444 per month. Even I love to get so much of discount whenever I purchase anything, and this is your chance. Use this code of AMB10 as a referral code whenever you make the subscription, so that you can get or avail for 10% of discount. Don't forget. Regarding the iconic subscription, I know that many of you are like, we want more features. So those who love more features than what I already have described, you should be going for iconic. In iconic, you will be given a personal mentor, matlab a person to help you with your academic activities throughout 24/7. Then live doubt solving classes will be there especially for you. Weekly reports will be given to you. For enjoying all these super cool features, you should be going for iconic. For 9-month subscription, you can see that per month cost is 2,556. And those who want discount, when I say those who want discount, I know that everyone would love discount, right? So use this as a referral code AMB10 and get 10% of discount and enjoy your learning with Unacademy, right? And if you make the subscription right now, still I think the offer is going on. You'll be getting an extra 4 months for CBSE and for Creative Corner subscription. So make this opportunity. Why it is coming again? And one thing, tomorrow, those who want to do more amount of questions related to combination of resistors and equivalent, finding out the equivalent value of resistances, tomorrow you can come and join in the Plus platform for a special class. It's completely free. I hope you know that. At 5:30, I'm having a class. So those who love to solve higher level problems of a combination of resistors, you can come and join. Okay? Yes. That's it. It's time for us to start with the chapter, and we'll be starting with the combination of resistors, but 2 topics that is being left which we haven't completed, वो तो पहले करेगा और उसके बाद then we'll start with resistors. Everyone, jaldi se jaldi, everyone, are you all ready for this? Are you all ready for the session to get started? Jaldi bata. Let's start. Yes, we are gonna start. बिल्कुल. हाँ हाँ हम start कर रहे हैं. Nobody is gonna stop us. Nobody is gonna restrict us. Everything is going to be on physics. Now jaldi bata, are you all ready? Show me some energy in the chat box. Show me some love. Show me some yo-yo signs. Show me some smiling faces. Jaldi, and do let me know that all of you are super ready. Anna, Palak. I'll check, Palak. You know that I was having so many classes at night. Obviously, I'll be checking and I'll let you know. ठीक है. Mansi, Rashi, Ameer sir ki legend, everyone is here with full of energy, right? Then why should we stop? Okay, who's restricting us? Nothing. Shall we start? Okay. You know that whenever the charges passes through a conductor, electrical energy is being produced. So don't you want to know the formula for the electrical energy produced and how this electrical energy is actually produced? Shall we? Including the entire concepts. So be ready with your notebook and pen and start noting down each and every points. देख ले. We'll take white color, है ना? So white is good. So ये है हमारा कंडक्टर. अच्छे से सुन ले. This is our conductor, two ends of the conductor. Okay. I'm applying a potential of VA at this particular end and a potential of VB at this particular end for a time duration of delta t. If the potential of VA is greater than VB, tell me what happens. Tell me what happens. If the potential of VA is greater than VB, a current will start flowing from a higher potential towards the lower potential. Let me mark it as I. Yes or a no? Yes. Now, when I say the current is flowing, a current is produced, what is actually moving? The charges are moving. If a current is moving for a time duration of delta t, can you tell me how much is the amount of charge that has flown from the point A to the point B? Jaldi. Ha. With a smile, everyone can tell me. The charge is equal to the current multiplied by the time duration. Matlab, during this time duration, a charge Q is flowing from the end A towards the end B. है ना? Now, how many of you do remember this particular concept? The equation for potential energy when the charge is at the end A, how much is it? How many of you know? Electrostatics, we all have learned. What is the formula for potential energy? That is equal to charge into potential at that point. Yaad hai kya? Yaad hai? Okay, it is from electrostatics. Those who think that this is not there in your memory, जल्दी से जल्दी जाकर after this class do revise electrostatics. ठीक है. Then the charge flows, ऐसे flow करके it will reach at the point B. When it reaches at the point B, the potential energy associated with the charges at that point is charge into potential at that point. No doubts, I suppose. Now, who is having a larger potential? VA. So who will be having a larger potential energy? That will be for UA. When the charge is at the end A, it will be associated with a large potential energy. Let me ask you a very simple question. When the charge flows from the end A toward the end B, what is happening to potential energy? Is it increasing or is it decreasing? Is it increasing or is it decreasing? सोच कर बता. Yes, it is moving from a higher potential energy to a lower potential energy. The potential energy decreases. Yes or no? Yes or no? What is the change in potential energy? Delta U is equal to UB minus UA. How much is it? QVB minus QVA, Q into VB minus VA. So this is the change in potential energy, or we can say that this is the decrease in potential energy. Decrease in potential energy, which means when the charges are flowing in a conductor with the presence of a potential difference, potential energy drops. Which means, let's say 18 joules of potential energy is there. When the charges come to this point, let's say it become 12 joules. Potential energy has decreased. So what happens to this 6 joules? This 6 joules क्या है? 18 minus 12. Energy is always conserved. It has to be given to some other thing. So what is this potential energy converted to? अरे देख ले, the charges starts moving. So what is the energy associated with a moving charge? Yes, kinetic energy. So the decrease in its potential energy is converted as a kinetic energy of the electrons. And when the electrons starts moving, we know that it collides with the ions. When the collision happens, what happens? The particles stops, kinetic energy becomes zero, and what that kinetic energy will be converted to? Yes, heat energy. Initially, the decrease of potential energy, which will be converted as kinetic energy. The moving electrons will collide, and this kinetic energy is converted as the heat energy. So the amount of heat energy produced is equal to how much? The decrease in its potential energy. समझ में आ गया? Okay, समझ में आ गया? What is it? The amount of heat energy produced in a conductor is equal to the decrease in its potential energy. Q, I can write it as I delta T, and if the potential difference is marked as V, the formula is equal to VI delta T, which is the heat energy produced. Very important, understanding the concept, not just understanding the concept, also what? The final formula. Jaldi se jaldi, write it down. And also tell me, is the concept clear? And tell me, how do you feel learning physics by understanding the concepts to its depth like this? Sarav, current gaming, I need a girlfriend. Okay, stay here in the classroom till the end. I'll try to get one for you. ठीक है? So tell me, noted everyone? Have you all noted this down? Jaldi bata. And also tell me, I know that many of you do know the formula for heat energy is VI delta T. But how do you feel about understanding the concept of how this heat energy became VI delta T? Do you find it awesome? Do you find it awesome, everyone? Sasta, Jatin, Palak, Miara, you. Okay. So please do make short notes on how the heat energy become VI delta T. Okay, that's very important. Shall we proceed? Shall we proceed? So I think everybody have noted down. Okay. Now the last formula which we got was heat energy is equal to VI delta T. We know that I is equal to V by R. So even I can substitute for I here for getting different kinds of equation, but it is not required to by heart it. This equation you can by heart it, and you can substitute for whatever is given for finding out the unknowns. I'll show you an example. I is equal to V by R. Substitute kar le. This I equal to V by R delta T. This is equal to V square by R delta T, another formula for heat energy. Similarly, for VI delta T, you can even substitute for V is equal to IR. So you'll get I square R delta T. So any formula is possible by using these two. Fine. This is heat energy produced. Once again, VI delta T. Now, someone will also be asking what is the power which the heat energy is being released. Power matlab energy per unit time. How will you find energy per unit time? Energy per unit time divide on either side of the equation by time. Energy by time क्या हो गया? अरे energy by time हो गया power. So delta T cancels VI. The power at which the energy is being produced in a circuit is given as VI. Jaldi फटाफट लिख ले. Everyone copy this down. Done? Noted? नोट किया सबने? हाँ, with a smile. You can type my name and you'll get it. Noted Ameer sir की legend. तनवर में avocado अरे क्या है? I'm not able to get it. So I hope everybody have noted this down. So what do you all say? Shall we start doing the questions? Question का time आ गया. और क्या आ गया? Noted. And जल्दी से you all have 30 seconds. ठीक है? जल्दी से जल्दी फटाफट give me the answer for this. जल्दी. जल्दी जल्दी जल्दी. And let me see who is going to give me the answer as the very first person. Answer? I'm not able to find answer from anyone. अमर सर बन गया संघमित्रा. अमीर सर है ना मेरा नाम. अमीर भैया. Right? It's option C. That's अरे यार, I forgot to rub this off. अरे यार. Sir, you are the best. Thank you. So done. Is it done, everyone? Nobody have given me the answer. Akshaya says it's 0.9. Palak says it's 0.9. Okay, last 5 seconds to give the answer. 5, 4, 3, 2, 1. So everybody says it's option C. Let's look into it and let's find out. A 9-volt battery is connected to a resistor having a resistance of 10 ohm. What is the current? Okay, current is not there in the option. Everyone can find out current I is equal to V by R. Current is the first question. Ohm's law. V by R 9 by 10, which is 0.9 ampere. Everybody knows this. Power across the resistor. Power is equal to VI. V is 9, I is 0.9, 9 9s are 81, 8.1 with the unit of watts. I think I don't need to tell you separately what is the unit of power. You all have a very good base from your chotu classes itself. Hai na? Aur kya? So have a smile, and the option is C. I think everyone was super correct. Next question, jaldi, fatafat. I think the options are here a bit scrambled. I'm really sorry. This is A, this is B. This comes as C, this comes as D. Fatafat answer de de. Jaldi. Easy question, हाँ. I don't think there is a direct question can come from power which can be hard. So that's why I like, okay, ठीक है. Let me give you the straightforward question. So from here, jaldi. Everyone says it's option B, is it? Dalla says it's option B. Mansi says it's option B. So everybody, many of you are giving me the option as B. Then Mansi says option B. ठीक है. Very simple problem it is. Power is given, time is given, energy is a question. We know power is equal to energy by time. So energy is equal to power into time. Power कितना? 100 watts. Time, is it 1 minute? हाँ, 1 minute तो है, but we cannot substitute in minute because the SI unit of time is second. Make sure that whenever you do any calculations, everything is being substituted in its SI units. So ये कितना हो जाएगा? 100 into 60. 6000 joules. Option B is the answer. Okay. Chotu motu kaam hai, and things are done. Now, one last thing. I know that every one of you are waiting for the resistance to get started. Before starting with resistance, a small topic which we have missed, okay, from your NCERT part, which means give me 5 minutes, then we'll start with the resistors. Okay? 5 minutes, just 5 minutes. Now, I hope you do all remember what was current density. What we are going to do is, we are going to make an equation for a current density, okay, another equation for current density, and also another equation for resistivity. These are the two tasks that was left behind. We'll do it now within 5 minutes. Okay? आप लोगों को अमीर सर को 5 minutes दे सकता है ना? अरे यार मेरा हिंदी तो कितना अच्छा हो गया. देख ले. We know that current I is equal to V by R, isn't it? Or V, I'm going to write it as I into R. I, what is the formula for resistance? Everyone knows. Tell me, we can substitute it as such. Rho L by A. And if V is a potential difference which is applied across a conductor of length L, you know that an electric field is produced. What is the relationship between them from the chapter of electrostatics? The potential difference V is equal to E into the distance across the potential difference is applied, which is D. Here in this case it is L. So what can I substitute V as? E into L. Electrostatics, no doubts I suppose. ठीक है. So L cancels. So E is equal to, what is I by A? Rho is here, I by A is J. So here you have electric field is equal to J rho. What is J? Current density. E is the electric field and rho is the resistivity. An equation here. Okay, note this down. Very important. First Chotu derivation I suppose for every one of you. Next part. How many of you do remember this equation for current? I equal to NA drift velocity into E. सबको याद है? Okay. I'm going to take this A to the left hand side of the equation. What happens? I by A, it will be J. Okay. I by A will become J, which is current density. What is remaining? N. Drift velocity ka formula, how many of you do remember? E by M into 2, one more E. So I'm going to rearrange this. N E square 2 by M into E. I'm going to write E is equal to M divided by N E square 2 J. First equation, second equation. Try comparing. E, J, J. So what will be the coefficient of J will be from either of the equation if you compare? Yes, from either of these equation if you start comparing, you will get the value for rho is equal to M divided by N E square 2. Very important, do note it down. What is this? Resistivity rho is equal to, everyone, mass of the charge particle by number density of charge particle and the charge value of electron, which is 1.6 into 10 power minus 19 square. Tau is a relaxation time. Note it down. If you open your NCERT, you will be finding this equation. I don't want you to left out and don't think, I don't want you to think that, Ameer sir ने ये topic नहीं पढ़ाया हमको, है ना? You'll be telling, Ameer sir ने ऐसे किया हमसे. I don't want you to feel that. So note it down. It's also important. जल्दी बोल दे. Have you all noted it down? If you all have noted this down, it's done. It's time for resistance. And finding out resistance, I think you also love it, isn't it? Finding out the equivalent value of resistance. And this time it's going to be super fun and super amazing because we are having many different kinds of rules will be applied here. Yes. Okay, you can take a screenshot and please do make sure that don't take the entire time. Okay, and do write it along with me. ठीक है? So ठीक है, हम जा रहा है. So do take a screenshot and I think it still will be available. Myara, Agni, Priyu. Okay, let's start from the basics. The combination of resistors starting from the basics, okay, and then we'll be moving up the graph and by learning more and more and more advanced level problems. Ready, Anna? Be along with me. Write everything along with me and let's make it interesting by solving questions together. I'll give you 30 seconds of time for each and every questions and let me see how many of you can solve it. Let's start. Shuru kare. Starting with series combination of resistances. Okay, then we'll go for parallel. Say that we are having two resistors. 1, 2. I know that everybody do know this. Okay, but still listen. Because once you get the question, you will find out how difficult sometimes finding out the equivalent resistance will be. This is R1, this is R2. You are applying a potential difference of V. Now tell me how the current is distributed if resistors are connected in series. Jaldi. Yes. Current is the flow of charges. Whatever the charge flowing through the first, the same will be the current flowing through the second, which means current is same if resistors are connected in series. I'll tell you in the vice versa fashion, which means when you get complicated questions, how will you identify whether the given two resistors are in series? Check whether the current flowing through them is the same. If current flowing through two connected resistors are the same, we can say that those two resistors are connected in series. Note it down as a short note right now. Okay, an important point. Then, if you are applying a potential of V, some amount of V1 will be dropped across first resistor and V2 will be dropped across the second resistor, isn't it? So you can tell the total potential V is dropped V1 across the first plus V1 across the second. I hope you all know V equal to IR. Potential is equal to current into resistance. So what is the potential across the first resistor? Current passing through that, which is I, into its resistance, R1. V2, potential across the second, current passing through it, I itself, which is the same as is a series, into R2. हो गया? Huh? Then the total potential can be written as total current into total resistance. Let me put it as R. Total voltage is total current into total resistance. So R हो गया R1 plus R2. I hope everybody knows this, right? If there are 3, R1 plus R plus 2, R2 plus R3. If n number are there, R1 plus R2 plus R3 plus R4 plus R5 plus R5, R6, R7, R5 till n numbers. ठीक है, हो गया तो वो. Now अब बता what is left. Now let us also discuss about the parallel combination of resistors. First, second, ऐसे, 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 ऐसे. ठीक है. So we have two resistors. Okay, connected in parallel. Now, the next method which will help you in solving or which will help you in finding whether the resistors are connected in parallel or not. What do you have to check? Check this thoroughly, whether both the ends of the resistors are connected or not. If both the ends of the resistors are connected, then we will say that the combination is parallel. Okay, if this happens, you can say that the resistors are connected in parallel. Okay, let's see how the distribution of current and potential is across both of them. This will produce a current in the main circuit. Let's say I. Either aa jayega I. What happens? Flow of the charges. Now the charges has two different channels to flow, so it will get distributed. And let's say the current passing through this is I1 and through this is I2. So what you can say? The total current I ho gaya I1 plus I2. Simple. I is equal to V by R. Tell me, what is the potential drop across the first and second? इधर का potential difference कितना है? अरे, across this point is the potential difference of V acting. Same, across this resistor also देख ले, the potential difference of V is acting. So, across both the resistors, the potential difference is the same. No problem, I suppose, है ना? बिल्कुल बढ़िया. Okay. Now, I1 current is equal to V by R. So, current I1 across the first resistor is potential difference across them divided by its resistance plus current through the second resistor is equal to whatever is the potential across that, how much is it? V by its resistance R2. हो गया. And the total current is equal to total potential by total resistance. I am keeping it as R as we don't know. हो गया. V तो cancel हो गया. 1 by R is equal to 1 by R1 plus 1 by R2. If three numbers, 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. If n numbers, 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus ऐसे. Okay, till the nth number, you just have to add the inverse of it. बस. Then, ये भी देख ले. Sometimes there will be n resistors connected in parallel, but all of them having equal values. In that case, what will be the equivalent resistance? Some cases we can learn. That is 1 by R plus 1 by R. What is the case? n resistors are connected in parallel, all of them are having equal resistance of R. So 1 by R equivalent is 1 by R plus 1 by R plus ऐसे n times 1 by R. So 1 plus 1 plus 1, why? Denominator is the same, है ना? ये हो जाएगा n divided by R is 1 by R equivalent and R equivalent हो जाएगा R by n. You can use this whenever you get a question directly. If n number of resistors are connected in parallel, equivalent resistance is R by n. Okay. Then if two resistors are only connected, you don't have to do this all the time. You can cross multiply from here itself. How much will it be? 1 by R is equal to R1 plus R2 cross multiplying divided by R1 R2. So R हो जाएगा inverse ले ले R1 R2 by R1 plus R2. Okay, done. Everyone, वही है बस. Do note it down. ये तो बहुत simple है ना? बहुत simple मतलब छोटू छोटू है. I know that. But the questions will be a bit थोड़ा spicy हो जाएगा. Okay, थोड़ा hard हो जाएगा. कोई बात नहीं. Okay, we are gonna see all the kind of question that is gonna pop up for examination. हम करेगा various and legends together. I love physics so much. अरे बाप रे. इंग्लिश अच्छा नहीं लगता है क्या आपको सुशांत? जल्दी बोल दे. Noted everyone. सबने लिख लिया? What do you all have to note? This, second equation, third equation, and you can also write this equation. Noted? So shall we start with the questions? Ready? Ready for the fun part? Everyone, go for it. Very first question. 18 volt. 3 resistors are given. जल्दी से जल्दी give me the answer for resistance. जल्दी से जल्दी, तुरंत से तुरंत. Everybody noted. जतिन म्यारा, अग्नि, आर्यन, राशि, अमीर सर की legend, जतिन, पलक. Good. Kitty. Option जल्दी. Very simple it is. Anybody? I'll just wait for 15 seconds more and whoever gives the answer, बढ़िया. Everyone is telling option B. Is it option B? This is option B which says 2 ampere. Check. Everyone says B. Hana says A with 3 ampere. Then Sushant says A. Sudeep says A, B, A, B, A, B. I can see A, B, A, B, A, B, A, B, A, B, A, B. So let's see whether it is A or whether it is B. Whether it is A or B, my name is there, है ना? Ameer Basith. ठीक है, देख ले. Question is, what is the current? Current का formula, as we all know, V divided by resistance. V का value everybody knows, which is 18. But here combination of resistors are there. For finding a total current, you need the total resistance. है ना? बिल्कुल, कर ले. Start moving from here. When you move, you have the first resistance, and now the current is getting distributed, and the ends of these two resistors are connected together. So these two are in parallel. What is equivalent resistance in parallel? R equivalent is equal to, we already have written, R1 R2 by R1 plus R2. याद है ना? 6 into 3 divided by 6 plus 3. This is 18 divided by 9. ये हो गया 2. So this 2 together, I can replace it with a single resistor, isn't it? These two together will be with a single resistance of 2 ohm. Now look, this 2 and this 4, how they are connected? In series, right? Because it's the same current which passes through both of them. So what is equivalent? 4 plus 2, ये हो गया 6 ohm. So the total resistance of the circuit is 6, total voltage is 18. अरे current तो ऐसे ही मिल जाएगा. V कितना 18, टोटल R कितना 6, ये हो गया 3 एम्पियर। अरे B बोल रहा था आप सब लोग, अरे ऑप्शन A है। Now itself you started. This was the simplest question. Let me tell you, this is the simplest question you can find in the equivalent resistance. So it's option A. हाँ yes Aryan, it's option A. अब ठीक हो गया Bhavan? Is the confusion over? ठीक है? Okay, very good, very good. It's fine. कर ले ये, जल्दी से कर ले. This is finding out the equivalent value of resistance. Let me see how many of you can do it. People says it's option A. I'll tell you, this is 4 ohm, this is 4 ohm, okay, this is 4 ohm and this is 6 ohm. First you can do it in the actual method, okay, then I'll also tell you a small trick by which you can get the answer ऐसे. Anybody? Everyone says it's the option A. अच्छे से देख ले. Everybody is giving option A. ठीक है. So yes, let's see how to solve this. अच्छे से देख ले. All these concepts are very important. Okay, and finding out the equivalent resistance here is also so important. So ध्यान से, ध्यान इधर है ना सबका, सबका ध्यान इधर है ना, देख ले. ये 4 है, ये 4 है. How they are connected? Tell me. देख ले, if a current of I1 passes through this, it's the same current which passes through this 4 also. So ये दोनों connected in series. So 4 plus 4, R1 plus R2, how much is it? 4 plus 4 हो गया 8. So I can replace this 2 resistors with a single resistance of how much? 8 ohm, right? Because these two combine together to have a single resistance of 8 ohm. Now tell me how all these three are connected. Here you have 8 ohm, here you have 4 ohm and here you have 6 ohm. How they are connected? देख ले, their end points are connected together. So how they are connected? In parallel. Use a formula. 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. You can use any method. Okay, so 8, I'm going to cross multiply with 2 so that you have common denominator. So 2 plus 1, 3 by 8 plus 1 by 6. So ये हो गया 6 3s are 18, right, plus 8, that is 26 divided by 8 6 are 48 is 1 by R. So R is equal to 48 divided by 26. So almost you will get an answer of 1.85. Okay, which is option C is the answer. देख ले. So we have done this in the real method. Now shall I tell you what is the simplest method? For the simplest method you should be knowing this simple concept. I'll tell you this concept. I hope everybody have noted down. Noted है ना? पूरा का पूरा लोग हो गया. देख ले. I'll tell you a small concept here so that without doing any calculation, by looking into the option you can tell, हाँ, this is the answer. Don't you want to know that concept? देख ले. Let me tell you, two resistors of 2 ohm and 4 ohm are connected in parallel. What is the equivalent? Tell me what would be the equivalent value of resistance if these two are connected in parallel. R1, R2. Resistance formula R1, R2 by R1 plus R2. This is 2 into 4, that is 6 divided by 2 plus 4, that is 6. ये हो गया 1 ohm. Tell me what can you observe from here? 2 and 4 are connected in parallel, and when you find out the equivalent value of resistance, the value which you are getting is lesser than both of these resistors combined. Whatever are the values of resistor that is undergoing the combination or parallel combination, the resultant, whatever you are observing, will be value lesser than both of them. One is lesser than 2 and one is lesser than 4. So in parallel, the effective value of resistance will always be lesser than all the resistances that is connected in parallel. Can you note this down, everyone? In parallel, those who want me to write, in parallel, equivalent resistance is always lesser than its resistors in parallel. Note this down, very important. Based on this particular concept, you can actually solve that problem. Shall we? Dekh le. The resistors that is getting combined here are in parallel 8, 4 and 6, isn't it? So the effective value of all the three resistors in parallel will be a value lesser than 8, lesser than 4 and lesser than 6, which is the least among them 4, which means it will be a value lesser than 4. How many options can you see with a value lesser than 4? How many? Only one single option. Which one is it? Option C. So those who know that particular concept, can't you go for the value SA directly? Yes or no? Yes or a no? Jaldi bata. Okay Palak, bye bye. EMI chapter is done, Nitish. हाँ, what is your doubt, Sushant? जल्दी बोल दे. So I hope this answer you all have got it. है ना? Okay, yes, 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 yes. So अगला question, ready? Yes, everything is beneficial. It is beneficial. अगला question कर ले. जल्दी से कर ले. प्रतीक शर्मा, yes. Agla question, jaldi, jaldi, jaldi. I'll give you just 30 seconds. Tell me which option it is. Here you have to find the equivalent value of resistance and then you have to find the current. हाँ, रवि रतन नाम तो ले लिया आपका. Happy? ना जल्दी से आंसर दे दे और मुझे भी हैप्पी करा ले. Options are 0.05, 0.1, 0.2 and 0.4. Who says option D? Sushant says option D. Then anyone else? Nitesh says 4. There is no option like 4, which means did you mean option D? Okay, so I can see some people giving option D. Dekh lega. Dekh le, everyone. Question is, what is the total current? How will you find total current? Total voltage by equivalent value of resistance. But this figure looks a bit tricky. You are not able to find out how these resistors are connected. Array, it's very simple. Okay, so just say the current passes through here and reaches at this junction. After reaching at this junction, how the current is going? One of the current will be passing through this branch and the other will be passing through this. And you know that it is the same current which passes through all these 10 ohm. So, and it will be joining here. Tell me how this 10 and this 10 are connected. Jaldi. Array, same current, all these are in series. So, between these points, dekh le. So, between these three, this will be connected in series. So, how much will be the equivalent? 10 plus 10 plus 10. How much these three will count up to 30. So between this point, if I mark as A and B, if I have the point A and B, these three resistors get add up 10 plus 10 plus 10, that is 30 ohm. हो गया है ना? Then ये भी 10. How they are connected? Between the points A and B. एक और 10 है. Now हो गया ये 30 and ये 10. How is it connected? अरे जल्दी बता. हाँ, it is connected in what? Parallel fashion. So R equivalent R1 R2 by R1 plus R2. हो गया 30 into 10 by 30 plus 10. How much is it? 40. So this is equal to 30 divided by 4 हो गया. R equivalent मिल गया तो क्या बाकी है? Current तो बाकी है. Current is V, that is 3 divided by resistance, that is 30 divided by 4. 4 goes up. 3 cancel, 10 is remaining by 4. 0.4 ampere. बस हो गया, मिल गया. Option D है. If anybody is here who haven't understood, let me know. Very simple, छोटू problems. जल्दी बता. Is it clear? Yes, 0.4. Yes, Shweta, Myara. Very good. Yo. Correct. How many of you got it correct? Jaldi bata. And those who are having any trouble, those who have got it wrong, please note down the correct formulas and the correct step and write down the final answer, which is 0.4, option D. No, we cannot do by Wheatstone. Anand Kumar, we cannot do it by Wheatstone. This is not the Wheatstone condition. We'll talk about Wheatstone. Okay. Yes. So अगला question. बोल दे sir, अगला question दे दिया मैं. Now it's your responsibility to give me the correct answer. जल्दी फटाफट. अरे जल्दी दे उत्तर. Clear है ना शगुन राशि? अरे if I sit here you can't see the options. हाँ, I'll stand here. Who is sir, class time for 11th standard from 8 o'clock and for 10th standard 10 o'clock. Happy birthday. मेरा birthday तो बहुत पहले था. अरे option C बोल रहा है. Who is telling option C? Bhavin Kumar says option C. Sushant says option C. Priyu, nobody says. Sushant says option C. Very good. अरे बिल्कुल सही है. Yes, it is option C. Very good. Question is the value of equivalent resistance between the point A and the point B. I know that many of you will be having trouble in understanding that these four resistors are connected in parallel. When I say हाँ ये तो parallelly connected है, everyone will be like ऐसे कैसे sir, how can this happen? So whenever you come across these kind of diagrams which is so difficult, what will you do? Just redraw the diagram between the 2 points which is mentioned A and B. Okay, redraw. This is point A, okay, and this is point B. Now connect those 4 diagrams between 4 resistors between these points and see how they are connected. Shall we? Let me mark first resistor, second resistor, third resistor, fourth resistor. First one end is connected to A, other end is connected to B. Go for the second, one end is connected to A, other end is connected to B. Third resistor, one end is connected to A and the other end is also connected to B. Go for the fourth one end is connected to A, the other end is connected to B. How all these 4 resistors of resistance of equal value of R are now connected. Now everyone can understand. Yes, they are connected in parallel. So R equivalent 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. ये हो गया 4 by R. So R equivalent is equal to R by 4. Arey yaar. So option C is the answer. Very good. Many of you have given the answer. बिल्कुल बढ़िया. समझ में आ गया सबको? थैंक यू नीतीश. तो ये समझ में आ गया नहीं नहीं आ गया? जल्दी बता जल्दी बता जल्दी बता. Okay. Yes. Okay. Very good, very good, very good. You'll watch replay. क्या हो गया मेरा? In paid course webcam is required. कौन बोल रहा है ऐसे ले लिए सब? अरे पेड कोर्स पे आप लोग नई क्लास ले रहे, टीचर्स क्लास ले रहे, उसको चाहिए वेबकैम है ना. अरे यार whatever. So this is a basic concept by which we'll be finding out the equivalent value of resistances. We try to do as many problems as possible, but you know that practice can only make you so perfect. So try to do as many problems as possible. You will find so many questions in finding out the equivalent value of resistance from many of the books. So try exploring, try to do as many problems. It is so much sure that one problem you will get from this part for JEE, NEET or for your board examination. So it is worth spending time for this particular topic of equivalent resistance. तो हमारा simple तरीका of finding equivalent resistance is over. Now देख ले. Do you want to try? I don't think there is no point of me giving you some time for trying, because you don't know how to apply this, right? There are certain other rules, which means rules of symmetry, which you have to learn, then only we can do it. Shall we learn all those rules of symmetry for finding out the equivalent value of resistance in this complicated cases, super complicated cases? I'll explain you first that, then try to give me the answer for this. ठीक है. देख ले. First rule of symmetry. First rule of, okay, symmetry. It's very important. First rule of symmetry. Let's say you are applying a potential difference between the points A and B, right? So many resistors are there, let's say suppose, and between the points A and B, if you can draw a plane, it's not a line, a plane. Look at my palm, it's a plane. If you can draw a plane passing perpendicular through A and B, which can cut the A and B structure exactly and symmetrically into two, then we can say that the perpendicular rule of symmetry exists. What is it? If you are applying a potential difference of A and B, and if you can keep a plane perpendicular to the line A and B, cutting this entire circuit symmetrically into two, then we can say that the first rule of symmetry or perpendicular symmetry exists. If this symmetry exists, we can say, write it down, all points on this plane will be having same potential. Okay, all points on this particular plane will be having the same potential. This is the first rule of symmetry. I know that many of you might have understood this particular thing only to 30 to 40%, right? Don't worry, that's why we are going to do an example here and make you understand to its depth. देख ले. This is the point A. Everyone listen, very important it is. If you are a 12th standard student, if you are going to appear for a JEE, NEET or for board examination, these kind of question pops up. A resistance 2 ohm, 3 ohm, 5 ohm, 5 ohm, then 10 ohm. Question is, find out the equivalent resistance between the point B. Obviously, we can do it by Wheatstone bridge. That we'll be learning later, right? Now, let us understand the concept of first rule of symmetry or perpendicular rule of symmetry. It says, if you are having 2 points A and B where the potential difference is applied, and if you can cut this entire structure exactly into two by drawing a plane perpendicular to the line AB, okay, does a symmetry exist, which means on either side of the line can you see the exact half? Okay, either it is 2, 5, so let me make it as 2, I'm sorry. So here it is 2, here it is 2, here it is 5, here it is 5, which means this looks exactly symmetrical on either side. Then the perpendicular rule of symmetry exists. And what does it say? It says all the points on this line are having the same potential. If this is V, this will also be V. Then you'll be asking, sir, what is the use of this? If we get to know that all the points on this line are same potential, if the symmetry exists, what is the use of this? Arey soch le. Current will only pass through a resistor if there exists a potential difference. Here the potential is the same according to our first rule of symmetry. So if potential difference is same, current passing through them will be 0. Yes or no? If current is not passing through this resistor, do you actually need to consider this resistor? No. समझ में आ गया? So how can you redraw this diagram after the application of perpendicular rule of symmetry? Starting from the point A, you have the first resistor, you have the second resistor, you have the third resistor, and you have the fourth resistor. Now finding out the resistance, it's not a big deal at all, है ना? देख ले, now 2 and 2 are in series, ये हो गया 2 plus 2. This is 5 and this is 5 in series, ये हो गया 5 plus 5, which is 10. And this 4 and this 10 are connected in parallel. अब समझ में आ गया? समझ में आ गया सबको? जल्दी बोल दे. It is very important, super important it is. हाँ, symmetry theorem super important. जल्दी बोल दे, ये समझ में आ गया या नहीं आ गया? Yes? Okay, someone are telling bit confusing. What do you have to do for applying the first rule of symmetry? Okay, look into the figure. Try to draw a plane perpendicular between the points A and B where potential difference is applied. After drawing this plane, if the plane can cut the structure exactly symmetrically into two parts, then we can say first rule of symmetry exists. And if it exists, what can we apply? All the points on that particular plane will be having the same potential. So here you can see that if the potential across this resistor is the same, potential difference will be 0. If there is no potential difference, current will be 0. So no current will be passing through this resistor. We can remove it. And the resistance equation or the diagram becomes like this, where you can easily solve it. अब समझ में आ गया? हाँ? So how many of you, ये नोट किया है ना सब? First rule of symmetry or perpendicular rule of symmetry. You can write both. Note this point down. Okay, and to understand it better, write down this example also. Okay, done I suppose. Shall we do the next question? Let's see how many of you can do it. कर ले. Okay, so this 1 minute. This has to be the second rule of symmetry has to be applied for doing that. Okay, I'll explain the second rule of symmetry also. ठीक है? Okay, before going with the second rule of symmetry, okay, that question is again based on second rule of symmetry. I'm really sorry for that. So I'll give you a question all by myself. Try to give the answer for that in your own words. ठीक है, देख ले. So it starts like this. Let me say we have a resistor like this, and okay, yes, then all are having tell me the value of this. I'll give you options also. Okay, option S is, let me calculate. Okay, option B says this is equal to 3R by 2. Option C says R by 2, and option D says 7R by 2. जल्दी फटाफट ऐसे ये क्वेश्चन बनाया. Which option? R R R R, ये 5R और ये R. Which answer can you give me? जल्दी बोल दे. Who says Ainthak says option C, Kunal says option C, Agni says option B, then everyone jaldi fatafat. So Priyu says option C, and A says R by 2. So many are giving the answers, right? Rashi says C. So let's see how this can be done. Now this is a question which you can do in different methods, but one of the method by which you can do is like first rule of symmetry or perpendicular rule of symmetry. So what does it say? It says between the points A and B where potential difference is applied, if you can draw a plane perpendicular to this AB and cut the structure symmetrically into two, then the perpendicular rule of symmetry exists. Does a symmetry exist? Right? R R R R, and this R is divided into 2. Yes, a symmetry exists. And what does it say? If the perpendicular rule of symmetry exists, yes, it simply says all the points on this plane are having the same potential. Now if you look at these 2 points, if the potential are same here, will a current be passing through it? No. Why? Because potential difference is 0. Only potential difference can produce what? A current to pass through it. So इससे current नहीं जाएगा. मतलब there is no point of having this resistor here. So can't we just redraw this figure without that resistor? देख ले. Starting from the point A, we have our first resistor, then our second resistor, third resistor, fourth resistor, and the fifth resistor. All are having R. Now it became simple once you have removed this 5R, है ना? देख ले, ये R and ये R are in series. R plus R, 2R. ये R are in series. If you connect these two, 2R again, and this R. How all these are connected? Jaldi bata. These all will be connected in parallel between the points A and B. So 2R, 2R and R. Formula: 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 is R. Okay, what I'm going to do is multiplying with 2 to have a common denominator. 2 plus 3 plus 4, 4 divided by 2R ये हो गया. उल्टा कर ले. R equivalent is 2R by 4 or R by 2 is a final answer. Okay. So understood this perpendicular rule of symmetry and how to use this perpendicular rule of symmetry. Jaldi bata. Jaldi. हाँ, and have you all noted this down? And सबको समझ में आ गया तो मज़ा भी आ जाएगा, है ना? हाँ सर, बिल्कुल मज़ा भी आ गया. मज़ा आ गया तो थोड़ा हंस ले. Let me see some smile on your faces. So this is which rule? First rule of symmetry, very important, and you can understand very good. Others, yo, noted everyone. Jatan, Amiara, आ गया है ना? बिल्कुल. राशि noted. Everyone, very good. बिल्कुल बढ़िया. तो let us learn the second rule of symmetry. Okay. देख ले. Now let us understand the second rule of symmetry. Everyone listen here. It's super duper का भी important है. So learn along with me. The second rule is, if you are having 2 points A and B where the potential difference is applied, okay, and if you can draw a plane parallel to the line AB and passing through AB, and if this plane is cutting the entire structure symmetrically into two, then we can say that according to second rule or horizontal rule of symmetry, we can say that if we can draw a plane passing through line AB, and if this plane can cut the entire structure of resistors exactly symmetrically into two, we can say that mirror points are having same potential. Okay, so I have stated what the theory is. ठीक है, I know that you might have understood chotu only like last time. Don't worry, we are going to do the example which can understand or which can help you understand the concept to 100%. So I want everyone to listen to this example. ठीक है, अच्छे से देख ले without even moving your blinking your eyes. It's very important. So let me have a structure of resistances. ये R है, ये R है, ये भी R है, another R, another R, another R, ये भी R. अरे बाप रे सर कितना R करेगा आप. So यही R है, and these are the points across which the potential difference is applied, and these are the points where you are supposed to find out the equivalent value of resistance. Okay, shall we apply the second rule? Shall we apply? Yes. The second rule of symmetry says, if you have 2 points where A and B where potential difference is applied, and if you can draw a plane passing through the line AB, let me try drawing a plane AB passing through the line AB, and if it cuts the entire structure of the resistor symmetrically into two, is it cutting? RR, RR, RR. Yes. Then what is said? If this symmetry exists, it says mirror images will be having the same potential. If this is having V1, this will also be V1. If this is V2, what is its mirror point? This will also be V2. This is what the horizontal rule of symmetry says. Okay, learn it by heart. It's very important. This is the second rule of symmetry. Done? Everyone? Done. Okay. Now देख ले, if the potential across this resistor is the same, will a current be passing through it? No potential difference. What we can do? अरे remove कर ले. Nobody need this resistor. Okay, बिना काम वाली है ये. What about this R2? The potential difference across them is 0. Why? the potential at both of its ends are the same. So no current passes. ये भी बेकामी है, we don't need. जा भाई जा. So हमारा काम तो अभी आसान हो गया. देख ले, from A it passes through ऐसे ऐसे ऐसे, मतलब ये R in series. How much? R plus R. ये हो गया 3R. Similarly, ये भी R 3R. And how the upper 3R and the lower 3R are connected? They are connected to the same points of A and B. ऐसे. So how these two 3Rs are connected? In parallel, right? So 1 by R equivalent is equal to 1 by 3R plus 1 by 3R. I am writing the calculation as such. 3R by 2 will be equal to R equivalent. This will be the final answer. समझ में आ गया सबको? जल्दी बोल ले. Is it clear to everyone in the classroom? जल्दी बोल दे, जल्दी. अरे it's already 11:20. आज का टाइम ऐसे ही गया. I also didn't notice. Okay, so third rule of symmetry we'll be doing it later. अमीर सर की लेजेंड बोल रहा है, क्वेश्चन चाहिए, है ना? शगुन, म्यारा, अग्नि, अनिरुद्ध, स्टाइलिश रजपूत, क्रिस्टल क्लियर. अरे बाप रे, ठीक है. Now do this. Try to do this problem and give me the answer फटाफट, जल्दी से जल्दी. जल्दी उत्तर दे दे मुझे. जल्दी उत्तर दे दे. Okay, when you get these kind of big problems, you can try both the symmetry. First you can start with perpendicular axis of symmetry and check whether symmetry exists, then parallel axis, then check whether symmetry exists, and accordingly do it. Is it done? Is it done? Anybody gave the answer? Anand Kumar says it's option B. Then Shriya, every day at 10 p.m. Not every day. Next class is on Monday. Okay, usually Monday, Tuesday, Thursday and Friday will be the classes. Might be D, might be A. Nobody is so damn sure about it. Try with a perpendicular axis. If you draw an axis perpendicular to the A and B, is it symmetrical? 3 here, 4 here, 3 here, 4 here, 3 here, 4 here. It is not symmetry. There is no symmetry. Perpendicular axis of symmetry doesn't exist. Then check for parallel axis or horizontal. Check 3, 3, 4, 4. हाँ, ठीक है. Parallel axis of symmetry exists, right? You just have to draw a plane passing through AB and check whether the upper end and the lower end are looking alike. Yes, it is looking alike. So we can say that what? The horizontal symmetry do exist. Second rule of symmetry exists. If that exists, what you can say? Yes, the mirror points are having the same potential. समझ में आ गया? If the mirror points are having the same potential, will there be a current passing through these two resistors? नहीं, because देख ले, potential difference are the same. Sorry, potential is the same across it. So current तो ऐसे नहीं जाएगा, है ना? तो what you can do? Remove कर ले दोनों को. Okay, हट जा दोनों. Okay, we can say that. So दोनों को गया. Both of those 2 ohms are gone now. Isn't it? Yes. Now it became simple. देख ले, this 3 will use different color. This 3 and this 4 are now connected in what? Series, because there is no other resistors for the current to get distributed. Same current passes through them. So ye 3 and ye 4 are in series. How much? 3 plus 4. 7 ohms. Between the points A and B, it is 7 ohms, right? Then it is the same current which passes through this 3 and this 4. So this is also in series. How much is it? 3 plus 4, 7. Same. The same current passes through both of them. So 3 plus 4, again 7. So you have 3 resistors of equal resistance of 7 ohm connected in series. अरे बोल दे कैसे करेगा R equivalent? 1 by R equivalent is 1 by R1, 1 by R2, 1 by R3. ये हो गया 3 by 7. 1 by R is 3 by 7. R equivalent हो गया. बोल दो ना जरा. So is it clear? Everyone in the class? So who all gave me the answer as option B? Anna gave the option B. Then Agni B. Then और कोई नहीं है? Nobody else have given the answer. Yes, it's option B, isn't it? Yes, very good, very good, very good. बिल्कुल बिल्कुल बढ़िया. Yes, B आला विनय. B ही है. It's option B. Clear? Very good, very good, very good, very good, very good. So now it's a doubt time. One more rule of symmetry is there. Third rule we'll be doing in tomorrow's class. We'll be doing in tomorrow's class. Very good, Aintak. Jaldi bol de. Is there any doubts? Any doubts? Doubt time. Doubt time. Doubt time. Doubt time. Three minutes. Jaldi. I'll sit here. All ready to take in your doubts. And jaldi bol de. मेरा tomorrow onwards leave है ना बिल्कुल तो बिल्कुल okay Miara's doubt will be solved then Palak has sent me to check her what are short notes. I'll be looking into it. हाँ sure Anna बिल्कुल बिल्कुल अरे don't ask me to repeat something again because repetition you can just replay again, you can watch because I'll be explaining the same thing. है ना? So tell me, thank you so much Jatin. Just tell me if you have any doubts, specific doubts. ऐसे क्यों है? Why ऐसे क्यों है? और why this is this? कुछ है तो जल्दी बता. हाँ बिल्कुल बिल्कुल. Okay. So nodal analysis, I don't think it is there for your board exam. Let's see. Okay, and not for JEE mains also. So let's see if it is required, I'll take. Okay, Antak. Thank you so much. Thank you so much. So I'm not able to find doubts from anyone here in the classroom. So I think वो तो बिल्कुल बढ़िया. So I know that many of you want to do some extra problems, right? So those who want to do some extra problems, देख ले एक minute. So tomorrow there is a special class from my end where 5:30. अरे यार. Okay, at 5:30 there is a special class from my end where combination of resistors we can do lot many problems or finding the equivalent value of resistances. It will be so many multiple choice questions, right, which means high order thinking multiple choice question. It's going to be tomorrow at 5:30 special class. Okay, and one more special class will be there. Okay, one more special class will be there, not rolling motion, this is over. Okay, at 7 p.m. one more special class is there, how to prepare for your term 1. At 7, topic is how to prepare for term 1. Okay, at 7 o'clock we have this particular topic of a special class, and at 5:30 it is the continuation of today's class, which is a combination of resistances, which you will find it so much useful. So whoever want to solve higher order thinking questions, do come and join, and those who don't know how to join for special classes, I will tell you. So is it fine? The topics are clear to you? So those who don't know how to join for the special classes, what do you have to do? Go to Unacademy Learning app, okay, log into the app and select the menu button on the top left corner and click on special. Then you can search for me or the topic, and then they'll be asking you for the invite code, a code that you have to apply so that you can get into the class completely for free. It is AMB 10, use this. 5:30 class will be so much useful for you. Okay, let me tell you why. Because finding out equivalent value of resistance is an important topic. Okay, and at 7 you can understand how to prepare for term 1. How many of you are going to come? कौन कौन आएगा कल? जल्दी बता. How many of you are going to come? So I'm going to expect every one of you make use of this particular topic. Okay, yes. So then the code is this, and I hope you know what are the features of the special classes. You know, real time chats will be there, question tab where you can ask your doubts, then live quizzes, leaderboards. It's going to be so much amazing. So I can see Anna will be there, Sudeep will be there. Okay, AMB 10, not AMB ID. Then for term 1, crash course is there for 11th standard. Those who want to revise the 11th standard topics can come and join. This is the teachers panel going to be. Okay. Then a triple dhamaka offer is going on. I think I have already told you. And the code is AMB10. If you want to make any subscription, if you want to join an academy, I'm not telling if you want to, I will be telling. That will be a great benefit for every one of you. Come and join. And the code that you have to apply is AMB10. Use it and get enrolled as soon as possible. Many courses are getting started. I'm also starting many of the courses. ठीक है, so जल्दी से आ जाइए. And how many of you haven't liked the session? How many of you haven't liked the session? जल्दी से जल्दी फटाफट like कर ले सब. Everyone who loves Ameer sir and who loves physics, फटाफट like कर ले, and do let me know that you are loving whatever it is being taught in the class. ठीक है, बढ़िया. And yes, I think it's time to say bye bye and time to say good night. Okay, so bye everyone, good night. Next class is on next Monday. I'll be on leave for 2 days. Okay, I'm really sorry for that, but still. So bye everyone, thank you so much. Take care, good night. Signing out with Unacademy, and yes, let's crack it, whatever is the examination gonna be. So bye everyone in the class.